Welcome to Real GMAT Problems, episode 38. Doing real GMAT problems is one of the most data-backed ways to make sure that test day goes well. So let's talk through a few examples. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions that we're going to work through here. The official guide contains retired problems that have appeared on past GMAT exams, and so these are going to be very similar to what you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on what to take away from each one. I recommend pausing after I read through each problem and trying to solve it, or at the very least, visualize how you would solve it. You might not be able to execute all the steps in your head if you're on the go, but just do your best. If you're in a situation where you can physically write down what you would on test day, that's definitely ideal. We've done quite a few problems together in this series so far, and I think it's time that we start to tackle some of the more challenging questions. I'm still going to begin with a simpler warm-up problem, but we'll start ramping up a bit more from there in the difficulty spectrum than we have in the past. If you find these questions a little too tough, just go back to some of the earlier episodes in the 20s and 30s and return here when you're ready. Here's our warm-up problem. The problem says, if A, B, and C are consecutive positive integers, and A is less than B, which is less than C, which of the following must be true? And then there's three Roman numerals. The first Roman numeral is C minus A equals 2. The second Roman numeral is A times B times C is an even integer. The third Roman numeral is the sum A plus B plus C, that whole sum in parentheses divided by 3, is an integer. I'll read all that again. If A, B, and C are consecutive positive integers, and A is less than B, which is less than C, which of the following must be true? Roman numeral 1, C minus A is equal to 2. Roman numeral 2, A times B times C is an even integer. Roman numeral 3, the sum A plus B plus C, that whole sum in parentheses divided by 3, is an integer. Option A is Roman numeral 1 only. Option B is Roman numeral 2 only. Option C is Roman numeral 1 and 2. Option D is Roman numeral 2 and 3. And option E is all three Roman numerals must be true. Again, I recommend pausing here and getting as far as you can on your own, and I'm just going to dive right into my commentary. It's a great warm-up problem, a good distillation of a lot of valuable basic principles that we'll leverage on more complicated questions. First things first, as always, I recommend writing what's given and asked. We've got some important constraints here. For example, A, B, and C are consecutive. It's very easy to miss that. They're also all positive, and they're also all integers. Finally, A has to be less than B, which has to be less than C, and forgetting any one of those constraints can lead to disaster. So as a simple but powerful tip, it's worth having all those constraints written down. I think you'll see that become even more important as we progress through the difficulty spectrum. Okay, so we've got what's written and asked written down. What do we do next? There's a few strategy options on questions like this. You can use what I'll call a number theory approach, meaning you memorize or you develop an intuition for how numbers interact with each other, and then you use that to reason through what must be true and what doesn't have to be true in the problem. I've spoken about this a lot in recent episodes, actually, so I recommend checking out the previous two episodes, episodes 36 and 37, for a bit more on this if you want. But the summary is that this kind of approach is fast and dangerous. It's fast because it doesn't require me to write anything down, and also usually doesn't require much or any computation. So I would call it very seductive. It has a strong inherent appeal to it. There's so much time pressure on the exam, and we often have these kind of difficult emotions during the exam, like anxiety or lack of control. And so anytime we feel like we recognize something or that we can like control the test or dictate the pace to the test, that's just really, really appealing. But like I said, it's also dangerous. Otherwise, I'd recommend using it all the time. And it's dangerous because it does not require me to write anything down and usually does not require much or any computation. So the same things that make it seductive make it dangerous. But why is that dangerous? Well, the more things I try to reason through and calculate in my head, generally the more questions I'm going to get wrong that I know how to do, even if I know all the math behind them. And if you're in the investing world, like imagine just investing based on intuition and never doing actual diligence or like putting anything into the numbers or a spreadsheet. Imagine that. Or if you're in the marketing world, imagine just running campaigns based on intuition but never checking the stats. If you're in the tech world, imagine building features based on intuition but never validating them with users. I mean, you get the idea. Obviously, all of those approaches would be extremely fast, but like absurdly dangerous. Okay, so kind of extreme examples, and they're just analogies, and none of them are perfect distillations of the concept I'm trying to convey here, but they're reasonable proxies. So the key is if you're that person who has incredible intuition for investing, maybe you can get away with your entire career in your entire career without diligence. And honestly, if that's you, you should absolutely do that. That's a massive competitive advantage with no downside. Clearly, that's a good bet. But let's be real, the vast, vast majority of us are not that person. I'm not that person. And if you are, you're probably not struggling with the exam at all. So I'll try to clarify. If you're getting incredible results with an intuitive or reasoning based approach to number properties questions like this one, keep going with that. If you want to improve as fast as possible, it's usually not a good approach because if you don't naturally possess that intuition, developing it is really, really time intensive. It's definitely possible. It's not impossible to develop that intuition. So if you have a long timeline, a very long timeline, let's say like 6 to 12 months, and you're willing to make the investment in order to develop that kind of speed, just recognize that it's probably a 3 month process, maybe a little bit more. And for most of us, that's just not a good trade. It's not a good idea to try to trade 3 months of our study just to get like one or two more questions right, like 30 seconds faster. Okay. So I want to explore an alternative. And we've spoken about this a lot before, but it's so valuable. It's worth reiterating. I recommend just developing a clear, organized approach to testing numbers in these kinds of situations. That approach requires almost no memorization. It requires almost no time to understand how to implement it. And it takes just a little bit of time to condition yourself to do it well. So the odds that it takes you 3 months are like ridiculously low. Maybe it's like 3 days if you're really serious. It could even be like 3 hours, but it could be 3 weeks if you're really fighting it. The point is, that's usually a better trade for most of us. We're okay taking an extra 30 seconds on these questions as long as we can get them right and we can save 3 months of our life that we don't have to spend grinding on developing like a really deep intuition for number theory that for most of us, we're going to use on the GMAT and then just it's not going to be very relevant to the rest of our careers. So since most of you are going to be in that second category of person, again, I was back in the day, just to emphasize this, let's talk through how to test numbers well on questions like this one. Let's revisit our constraints. The numbers need to be consecutive, they need to be positive, they need to be integers, and A needs to be less than B, which needs to be less than C. A good rule of thumb is to try to pick numbers that are as small as possible and as easy as possible to compute. So here I'd probably just start with 1, 2, and 3. I'd probably use some simple rows and columns for my visual organization system. Something like A is the first column header with an A and then a less than symbol right to the right of that. And then to the right of that would be B with a less than symbol to the right of that, and then C to the far right. So under A, I would write 1, under B, I would write 2, and under C, I would write 3. So again, like comically simple organizational approach, but the key is that I can be very consistent with that approach, which makes it less likely that I'm going to make a mistake. And also it makes it easier to implement under time pressure. Like I can fairly easily condition myself to organize things that way. And then I just start testing each Roman numeral to see which ones work and which ones don't. So let's start with Roman numeral 1. That says C minus A is equal to 2. Well, that's definitely true in my case because 3 minus 1 equals 2. So I'll move to the next one. Roman numeral 2 says a times b times c is an even integer, and that's also true because 1 times 2 times 3 is equal to 6. 3 says a plus b plus c over 3 is an integer, and that's also true because 1 plus 2 plus 3 is equal to 6. So I haven't been able to prove that any of these needs to be true, but I also haven't proven any of them false. So I'll try some other numbers and I'll see what happens. And I'll invite you to go through a few iterations of this if you haven't tried this before. So feel free to pause and give that a shot. What you'll soon realize, though, is that all three Roman numerals work 100% of the time. So this is kind of like the downside of testing numbers is you may not get 100% certainty. So on these must be true questions where there's Roman numerals and combinations of things, it has a cost. But again, it's a time trade-off. If you're willing to have the process take months longer to get that certainty, then that option is there for you. But if not, I think you find that the trade here is very acceptable. In fact, many times when you're testing values, you'll have theoretical insights into the theory behind the statements. And that's part of why I like to lead with the number testing approach on these questions, because a lot of times the number testing approach can get me some traction. And then I'll be able to have some realizations about the number theory without having to spend months and months and months developing like a perfect approach to number theory. Now, again, coming back to the downside piece of like maybe not having 100% certainty, that's usually only a problem on Roman numeral questions, which are somewhat rare. But I do want to acknowledge it's not that this approach is like perfect. It has some downsides, but again, it's a trade. I think most of you will find that trade to be very good. Coming back to the like having the theoretical insight by testing numbers, in Roman numeral 1, it's usually easier for me to recognize that that's always going to be true with a few numerical examples. After those couple numerical examples, it kind of starts to make sense. Like, right, if they're consecutive integers, then the third one has to be 2 larger than the first one. And I've found that that translates really well to a lot of different types of thinkers and different types of test takers. So that's part of the reason I'm recommending it here in like a very generalized public format. Pretty much all of you are going to be able to get value out of this. Now, admittedly, this is not the toughest GMAT problem ever, and we're going to get to some harder ones in just a moment. So you may have read number 1 and instantly thought what I just said, like, okay, yeah, they're consecutive numbers. Like the third one has to be 2 bigger than the first one. That's totally cool. Again, just make sure that that kind of thing works 100% of the time for you. Otherwise, you can back that intuition up with a couple quick number tests to validate your number theory. That's still dangerous, but it's better than having no backup approach, like no safety net. Similar thing with 2, Roman numeral 2, after plugging in a few numerical examples, it might become obvious to you that at least one of the numbers has to be even. And that's going to be the case in any set of 3 consecutive integers. And if you're multiplying any integer by an even integer, the result is guaranteed to be even. Why that is a little beyond the scope of this lesson, but I'm sure we'll get there in time. In the short run, a quick web search can help you resolve any questions that you might have about that. But I don't want to get deep into the number theory here because, again, my strongest recommendation is like try not to go down that path, even though it's super seductive and a lot of courses and programs push it super, super hard. There's a lot we could say about that, but I'm just going to gloss over it for the moment. So the point is not to ignore the theory or ignore the theoretical knowledge. It's to have as many options as possible for attacking these questions. And it's also a good idea to know which is going to be the best bet in different situations for you personally, rather than having an overly generalized approach. And that's something I've found that a lot of courses do a poor job of because, like, by definition, most courses are very generalized. And so they're like, hey, everybody learn all this number theory. But they don't always tell you, like, okay, for you personally, this is the kind of situation where you might want to default to this number theory. And this is the kind of situation where you might want to plug in some numbers instead. So I'm trying to help you develop that intuition and just help all of us out who are in this situation. So again, we're going to see all those concepts playing out in the coming problems. Before I get to that, I know some of you just want to know, like, what is the best way? Like, just tell me what to do. And if that's you, then what I recommend is just memorize the theory in your class or program. but always default to testing numbers. Make testing numbers the first line of attack 100% of the time, even if you've memorized the number theory. And that way you can have theoretical insights without getting into the trouble that the leading with the theoretical approach creates. Okay. So if you're like, hey, just tell me what to do, man, that's the way to go. Okay. So again, we're going to see all that come up in these next more difficult questions. But for now, I'd recommend pausing and making a note to self if there's something you want to remember about this problem that you feel like can enhance your approach. Whenever you're ready, let's unpause and move to the next question. Next question, also a Roman numeral question. This question says, if the sum of n, the letter n as in nighttime, if the sum of n consecutive integers is 0, which of the following must be true? Roman numeral 1, n is an even number. Roman numeral 2, n is an odd number. Roman numeral 3, the average of the n integers is 0. I'll read that again. If the sum of n consecutive integers is 0, which of the following must be true? 1, n is an even number. 2, n is an odd number. 3, the average of the n integers is 0. Option A is 1 only. Option B is 2 only. Option C is 3 only. Option D is 1 and 3 only. Option E is 2 and 3 only. Again, recommend pausing and getting as far as you can on your own. I'm going to jump right in. In many ways, this is the perfect follow-up problem to the previous one, since on the surface, it looks super, super similar. So let's apply our very simple approaches and let's see if they help us out. So first, we've got a sum. So I would note that as something given. Then the integers are consecutive. And then that sum has to be equal to 0. So I would write all of those things down independently. It's a sum, it's consecutive, they're integers, sum equals 0. Then, of course, you can use a theoretical approach here if that's a fit. But if not, and you're not getting results with that 100% of the time, I recommend testing some values. First, let's just find a set of consecutive integers that adds to 0 and try to keep things small and as easy as possible to compute. So I'd probably use A, B, and C again as my column headers here. But there's no, you can add the constraints or use arrows to draw the constraints for A, B, and C however you like. But those would be my column headers. And then under A, I would do -1. Under B, I would do 0. And under C, I would do 1. So those are simple consecutive integers that sum to 0. And that fits the constraint of the problem. So I'm making sure I'm not violating anything at the beginning and getting into that problem I was talking about earlier of having to like double solve things. So I'd write those down. And then to the left or right, I'd just be sure to track the value of n so I don't end up making a mistake that I'm going to regret later with that. So in this case, I'd write n is equal to 3. And the good news here is we can immediately eliminate Roman numeral 1 because we've satisfied the constraints of the problem. And clearly n, which is the number of these consecutive integers that sum to 0, clearly n is odd in this case. So I'll go ahead and eliminate option A and option D since both of those include Roman numeral number 1. I can't eliminate 2 yet because n is odd, and we can't eliminate 3 either because -1 plus 0 plus 1 does have an average of 0. Now, that could be a moment of theoretical insight because the average of a set of numbers is equal to the sum of those numbers divided by the number of items. And because the problem tells us that the sum is always 0, that might be an opportunity to quote unquote prove that number 3 will always have to be true. Now, you might never have that insight, or it might take a few more number tests to make that insight. But it's a decent example of what I was discussing in the previous problem about defaulting to testing numbers. So at this point, I'd probably try a few more sets, something like -2, -1, 0, 1, 2. So n would be equal to 5 in that case. But you'll realize that 2 and 3 both still work. And anytime I try to make n even, like -1, 0, 1, and 2, I'll wind up breaking one of the constraints of the problem. In that case, the sum wouldn't be 0. Now, I could also try something like -2, 0, 1, and 2, but that also breaks the constraint that they must be consecutive. meaning that they differ by exactly one. So you can see how important it is to track those constraints. It's very easy to lose track of one of them and then just go down a really dark path on the problem. So relatively soon there, I'm going to convince myself that 2 has to be true. And by extension, I'll likely also convince myself of 3. And that would bring me to a correct answer of option E as an echo, which is 2 and 3 must be true, but 1 does not have to be true. So even if you never have a deep theoretical insight, it's still highly likely that you're going to get the problem right by testing values as long as you keep careful track of all the given constraints. That is super, super key. So it really just comes down to writing things down well and executing well. These two approaches work really well hand in hand, and that's an important key. And that's why I was saying on the previous problem that you want to make sure to develop an organized approach to testing numbers, not one that's poorly constructed or poorly executed. Almost any approach is not going to work if it's poorly executed. Maybe that goes without saying, but it's usually good to be reminded anyway. Now, hopefully, I just made that question sound or seem super easy. Hopefully. I don't know that it was, but what's really interesting is that almost twice the number of us that missed the first question, 14% of us missed that first one. Almost twice that number of us end up missing this one. 27% of us missed this question. So think about all the MBAs that you know, probably really capable, really intelligent, really diligent, hardworking people. Imagine 1/3 of them almost just fall right on their face on this question. Okay. It's just shockingly easy. So why might that be happening? Well, we've got a full 18% of us going for option C, as in Charlie, which means those folks found out that 3 had to work, but did not realize that 2 also had to be true. And I don't know 100% for sure why that's happening. So often. But think about it here. Think about it for 1 second. 1 in 5 future business leaders makes that mistake. That's a lot. My guess is people are just going too quickly. They're figuring out number 3 in their head, not writing much down, and then succumbing to time pressure, so not like thoroughly testing all 3 Roman numerals. And that's not that hard to imagine. My guess is virtually all of us have made mistakes like that. So it's definitely a mindset of executing well, but it's primarily about building good habits. And if you build those good habits now, they're going to be there for you under time pressure when you need them most, and you won't have to deploy any willpower to get them to happen. So that's part of the reason I'm encouraging you, hopefully being fairly heavy-handed in my recommendation here to be organized with what you're writing down. So if there's a note to self to make here, again, I recommend pausing and making that now. And then let's try one final question that by the numbers seems quite a bit tougher for all of us. Last problem here. Problem says if n, as in nighttime, is equal to 4 times p, as in purple, where p is a prime number greater than 2, how many different positive even divisors does n have, including n? I'll read that again. If n is equal to 4p, where p is a prime number greater than 2, how many different positive even divisors does n have, including n? Option A is 2. Option B is 3. Option C is 4. Option D is 6. And option E is 8. Again, I recommend pausing here and trying to get as far as you can on your own. I think this question has a few interesting features, but maybe the most interesting is that on the surface, it looks simpler than the previous 2. But as you read, you might have noticed there are quite a few more constraints to keep in mind here. So this question is a really interesting genre in that it tries to kind of like brute force your working memory into forgetting the conditions. And it's actually a really effective tactic since the vast majority of us can only hold about 7 items in our short-term memory at any given time. It's worth researching this if you're interested in it. But it's also a great problem to study because if you don't have a good approach to notation, meaning like writing things down well, and you haven't built good habits of visual organization on easier questions, it's really easy to miss questions like this one that are really no more mathematically complicated than the previous 2, but are are quite a bit more complex in terms of what you need to keep track of. So just to put some numbers to those thoughts here, 37% of us are getting this question wrong. So it's almost a 40% higher miss rate than the previous question. In practice, it might not seem that bad, but when the clock is ticking down and you just spent too long on the previous question or that kind of situation, it can be a big challenge to shake that off and execute well on something like this that appears on the surface to be a quote unquote easy way to pick up some time. That's a dangerous thought. So again, I'm going to re-emphasize a lot of the super simple but super effective habits I've emphasized so far. Write what's given and asked clearly and test numbers in an organized way. Let's write what's given. N is equal to 4 times P. Let's write P is a prime number greater than 2. Let's write that we're looking for different, meaning 2 times 2 equals 4 would not count as two factors. We need different factors, positive factors. So -2 times -2 equals 4 would count as 0 factors. Even, 1 times 4 would count only as one factor since 1 is odd and 4 is even. And including n. So if n is equal to 12, 12 would count as one of the possible divisors we're looking for. Now, of course, you'll need to know some basic definitions. And if you're just getting started with your prep, we've got a quick math refresher linked for you in the description of this content that's going to bring you up to speed. So if you're feeling like some of the terminology is a bit unfamiliar, I'd recommend checking out that series and then return to this one when you're ready. But assuming you understand all those terms, let's simply apply a number testing approach and see what happens. N sounds kind of complicated, and it clearly has a lot of constraints. So while it would be fine to plug in for N, I think it'll be a lot easier to plug in for P, since that has only 2 constraints. It's prime and it's greater than 2. So let's choose 3 for P. Again, it's small, easy to compute with, and it fits the constraints of the problem. So n is equal to 4 times p. So let's start by just writing n equals 4 times 3 equals 12. Again, just to make sure we don't do something silly that we'll regret later. So now all we have to do is list the divisors of 12 and figure out how many are different, how many are positive, and how many are even. Divisors are just numbers that yield an integer result when we divide 12 by them. And many of you probably learned to visualize these as factor pairs. I did back in the day. So that's probably how I'd write these divisors out on my page. So I've got 1 times 12, that's one factor pair. I've got 2 times 6, that's another one. And then I've got 3 times 4. And that's it. Those are all the factor pairs. So let's cross off 1 and 3. Those are not even. And there are no repeats. There's nothing like 2 times 2. So we're good on the different constraint. And they're all positive. So we're good on the have to be positive constraint, and we're including 12. So we should be good to go. If we count up how many numbers we've got there, we've got 2, 4, 6, and 12. And that yields 4 positive, even, different factors of n. And believe it or not, that leads us to C, as in Charlie, which is our correct answer. Now, of course, you're welcome to try a few more cases to validate, but that's actually not important in this problem, because if one of the answers works in this style of problem, which is not a Roman numeral question, then none of the 4 other answers can work. Once you've done enough problems like this one, sorry, looks like we got a tech issue. Oh, okay, back in business. Once you've done enough problems like this one, you'll realize that as soon as you get one answer that works, the nature of the question is that it has to be correct, because we can't have some answers working sometimes and not other times. That's actually a little simpler than the must be true questions that we worked through before, since those have the statements that may or not be true 100% of the time. So this problem can have only one answer, and that has to work 100% of the time. So we can get away with just one number test and be done, which is super nice. So I think that's a really, really good contrast to the previous questions, which have a higher accuracy rate, even though they're quite a bit longer, and they'll usually take a little bit more time to work through. So let's step back for a moment. Apparently, by the numbers, this question is 40% harder than the previous one and about 2.6 times harder, so 260% harder than the first question. And yet, by applying the same comically simple technique, we can actually get this question right faster and easier than those two questions. So if you've been thinking like, why is this guy always pushing me to write things down on all these easy problems? What's this guy's deal? Hopefully that's a good example and evidence that I genuinely care about you succeeding in this process and avoiding so many of the pitfalls that so many people get into, myself very much included, back when I was in your situation. This took me way, way, way too long. I'm trying to save you that time. So if you're the kind of person who's willing to do the work and willing to endure the challenges, I think you at least deserve a clear path toward improvement and some high quality guidance. So hopefully I'm giving you that. Unfortunately, what often happens is people give these really horrible sales pitches, and it's hard to know what's what as a student in this process. So we're doing our best to remedy that situation for you. Let's talk about some of the pitfalls here. I hate to sound like a broken record, but it's pretty much the exact same stuff as the prior question. Not keeping track of all the constraints and or moving too quickly with a theoretical approach that isn't well refined enough. Those are huge pitfalls here. Again, almost 40% of us are missing this one. Both are super common, and they're also super understandable. Like I said before, there are a lot of people in the space trying to sell you on their way of doing things. And I have nothing against sales. I have nothing against marketing when it's done ethically and when it's done well. But it's definitely upsetting to see so many really good people go down this path every year and just get into a bad program, and then you wind up giving up on the process because they feel like they put in so much effort and they're not seeing results. And it just happens all the time. In fact, I was super close to giving up multiple times in my process, and I'm super grateful that I didn't do that. Like, life is way, way, way better on the other side of this. So I just want you to know that wherever you are in the process, success is for sure possible. And it's highly likely that all you have to do is change your approach and condition yourself to use good habits as consistently as possible. And that's going to be very likely to make a huge, huge positive difference for you, especially if you've been struggling. So one final time, if there's a note to self to make on this problem, I recommend pausing and making that note now. And if you have questions about anything that we've spoken through here, you can reach us anytime at the GMAT strategy on current social channels, or you can email us. Our public email address is contact@thegmatstrategy.com, contact@thegmatstrategy.com. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, everybody. Talk to you all soon.